With larger molecules, we're going to have multiple central atoms. So what we want to do is we just want to go ahead, look at the first central atom, starting from one of the ends, and say that the next central atom, well, obviously it's one of the attached atoms for atom number 1. So we'll just think of that one atom and not think about the rest of the molecule extending further off. Then once we're done with doing the structure for the first atom center, we'll go ahead to the second central atom. And now we'll treat center 1 and center 3 and the extra atoms attached. That may not make a lot of sense the way I'm phrasing it, but I think it'll make more sense once you actually see an example of it. So for this first one, let's go ahead and look at CH3, CH3. So what we'll do is we'll look at the first central atom. We know that's going to be carbon. And when we think through what our Lewis structure looks like, we'll say we have carbon, we have our hydrogen, hydrogen, and hydrogen. And then it's going to go off to this next carbon. In other words, this next central atom, which will also have all of its own atoms. So we go on to the next central atom and draw in its atoms too. Now hopefully what I was saying a second ago makes a little bit more sense. Let me go ahead and just highlight something here. This is going to be the chunk for our very first atomic center. And I'll go ahead and leave it in blue for the moment. So when I go ahead and draw that in, I'd have carbon. Now I want to show a little trick here. I'm going to go ahead and put my first hydrogen in the plane of the paper. My next bond, I sure want to have that go to my second atom, and I want it to still be in the plane of the paper. Now why? Because now I've kept this in the plane. All these extra atoms can be in and out of the plane, and that's going to be easy to draw, especially if it's a really long molecule where we have a long zigzag. It's easiest to just put dead-end atoms out of the plane of the paper. If we make this whole molecule the long end, sticking in and out of the paper, things turn into a geometric nightmare to think through. So that's what I recommend. Put your next atom in the plane, put a hydrogen in the plane or something else in the plane, whatever, and then just put in the remaining atoms. So I've still got 2 hydrogens to stick on here, one coming forward, one going backward. You can see I've got my first atomic center. 3 hydrogens, and then the bridge to the next carbon. Now I go to my next central atom. Let me just highlight where I'm talking about for that one. Now I'm going to be focused on this set of atoms. So my carbon is already drawn. This bond has to stay in the plane of the paper. It's already drawn. And see how I keep them at the 109.5 degrees in the plane of the paper? I want to do the same thing down here. I'll stick my next hydrogen along that plane of the paper. Now I can have my next 2 atoms in and out. So I'll have one coming forward, one going back. Now, that said, if I were going to chain this even longer, I probably would have wanted the bond that's in the plane to be up here. Have my forward-backward sticking down here. Reason? Then the next atom in the chain is still going to be right there in the plane of the paper. And so we can kind of control things by doing those little tricks and tactics. And is it really inauthentic? No, because remember, this whole thing can actually spin around a little bit. It's not locked in along this bond. It's able to rotate, almost like a pinwheel. And so if we rotated this just a little bit over, let's just say this direction, then we'd actually have it so that one hydrogen was up here in the plane, and we have one coming forward and one going backward. That's kind of the shape that we'd be talking about for all of these. So let me go ahead and get rid of my ink, and I'll put up the more proper structure. Here we are. And let me get that back to the red ink. Here we are. And you can see this is what I've got drawn, just like I had a moment ago. I've got one hydrogen in the plane of the paper, in the plane going to the next one, in plane going down, then my up and down. Notice they're just using the wedge and dash like this. They're not using a dashed wedge, but they're still implying which one is forward and which one's backward with all these wedges. And that's a legit way to do that. So that's our ethane molecule in 3 dimensions, CH3CH3. And now let's go ahead and just look at our next. So our next molecule will be ethanol. And if you remember about our nomenclature, that means we're going to have CH3 once again, CH2, in other words, the ethane molecule, but with one of these hydrogens removed, and we're going to swap in an OH. The OL told us that the alcohol group, OH, was stuck on the end. Okay, so now what we're going to do is we're going to set up a Lewis structure for this. We'll have our CH3. And here I'm just going to use those quick rules of knowing that carbon is typically going to have 4 bonds. I'm going to use that same rule again. Carbon typically has 4 bonds. I've got my oxygen here. I know that oxygen usually has 2 bonds and 2 lone pairs. The 2 bonds can be 2 single bonds or a double bond. But we see that we're at our octet just like we should be. And finally we'll have our hydrogen here at the end. So what we're going to do is we're going to do our structure from each of these central atoms. You can see here we have 3 different central atoms. Our first one is going to be carbon. Let's go ahead and have our molecule drawn in. We always want to make sure we have that bond going to our next atom first so that it's in the plane of the paper. Now I can go ahead and put in all the other atoms on this one. I have a hydrogen up here, and I need to have a hydrogen coming forward and one going backward to have that little tripod set up. I handled this atom. Now I come to the next one. So carbon, I see that it's in the middle still. It's chaining to the next atom. So I'm going to want to keep that one in the plane of the paper. Go ahead and stick an oxygen there for the next one along. Notice I've already got 2 in the plane of the paper. That means that my wedge and dash have to be pointing the other direction, one forward and one backward. I have 2 hydrogens on that one that I still have to place. There's the hydrogens in it. I've got that atom handled, so we go to oxygen now. Now it's easiest to keep my hydrogen in the plane of the paper. And what we'll do is we'll just have our 2 orbitals for the oxygen. What I'll do is I'll just draw it like this, kind of implying that one is forward and one is backward. And we have to do our best job sketching that we can. We have notations to help us with these things, but remember, some things we just have to draw as best as we can and communicate the science that we're communicating. And this thing that we're communicating here is that one's forward and one's backward. This would be the structure for ethanol. Okay, and so here's what that would look like with their sketch. You can see that they're showing the tetrahedral geometry for each of these spots with their little triangled sketch there. You can see that we have our oxygen sketched in red along with the oxygen's electrons pointing out. But you can see that more or less they've got it sketched in the same way that we would have, although they are using the wedge bonds differently still. So that would be our overall geometry for ethanol.